All right, so I'm about to go over special cases of compound inequalities. I noticed that those were on the math lib yesterday. Now, on the test that I give you, it's more than likely just going to be or will split and will be the part in the middle. You're looking for the overlap of the two on and it's normally in the middle. Sometimes it's not. But those are the special cases I'm going to go over today. And then I'm going to touch all real numbers and infinitely many. All real numbers, which is the same as infinitely many, and then no solution. All right, so let's take a look at number one. It's going to be important that you pay particular attention to the graph, okay? All right, divide in the middle by 4, on the right by 4, and on the left by 4. So that's 3 less than n, less than or equal to negative 4. Okay, this is a special case because you see it has the larger number, but it's using less than symbols, okay? Then your smaller number is on the right side and it's using less than symbols still, okay? So you have to look at this. I'm going to break this up so you can see exactly what I'm talking about. All right, so I'm going to take a look at just this portion here. So, guys, remember I had told you if you use less than symbols, you must start with the smaller number and then go to the larger number. And then if you use greater than symbols, you must start with the larger number. And over here have the smaller number. Okay, but see, you can tell this is backwards now. This is backwards. It's the larger number and then the smaller number, but with less than symbols. So that's going to be something different. All right, but let's break this up. So this is 3 less than n, which is n greater than 3. Okay? All right, now let's go with this one. We're going to break this answer up. These are what I call tricky ones, okay? And it's n less than or equal to negative 4. Okay, so if I think about everything less than or equal to negative 4, there we go. Everything greater than 3 is right here. It's going to be an open circle. Okay. But look, guys, these are supposed to overlap, okay? They're supposed to overlap, but they're not overlapping at any point. You got this one going left and this one going to the right, and it's okay? It's supposed to be overlapping in the middle. So this one is no solution. Now, if it were an or problem, then that'd be fine. But it's an and compound inequality. They should overlap somewhere. They're not. Okay, let's take a look at 2. P plus 1 greater than negative 7 and 4P greater than 4. Just subtract 1 from both sides. We're looking at P greater than negative 8. Here, divide both sides by 4. So we're looking at P greater than 1. Okay. This one is also special because they're going in the same direction. They're going in the same direction and it's joined by and. Okay. Normally with these, they're either gonna, for ors, they'll split and go in opposite directions, or ands, they'll go in opposite directions. One to go right, one to go left, but they'll meet somewhere in the middle. Okay. But let's take a look at it. So make sure you're looking at these graphs, please. All right, and reading this statement correctly. All right, so I'm going to look at everything greater than negative 8. I'm going to put negative 8 right here. That would help if it were on the graph. Let me extend this a little bit. All right, everything greater than negative 8, guys, is to the right. That's everything greater than negative 8. And then we have everything greater than 1 is right here. So now you're looking for where they overlap. Okay, instead of these overlapping in the middle, guys, they're overlapping on the tail end. They're overlapping right here. That's going to be your solution. It's another special case because they're not overlapping in the middle. So they don't always have to overlap in the middle on and. Sometimes they'll overlap on the tails. When I say tail, I mean outside of the middle, okay? Just pay attention to the graph. So in interval notation, my solution would be, where they overlap, would be 1 to positive infinity. That's where they overlap at. But again, read this graphic correctly. Read this graphic correctly. Then see where they overlap for and. Now, if for and, the lesser number is greater than, and then the greater number has a less than in it, for instance, like this, suppose it had been p greater than -8, and then p less than 1, they would have overlapped in the middle because you got the smaller number going right and the larger number going left, and they will meet somewhere in the middle, okay? But that's greater than and greater than. So you do have these weird ones. Just pay attention to the graphs and where they overlap or what the graphs look like. Sometimes they don't overlap, sometimes they do. And sometimes they overlap in the middle, sometimes they overlap on the tail. But most normal ones overlap in the middle, okay, for and. Okay, so while still on and, I'm not going to do all of these, guys. I'm just kind of bouncing around here. All right, we're going to subtract 7 from both sides here. And when I divide, you got n less than -1. Here I'm going to add 10 to both sides. When I divide both sides by 2, I get n less than 4. So I'm going to graph what I have. Keep in mind these are supposed to overlap somewhere because it's joined by n. All right, everything less than -1 is that way. And then let's look at everything less than 4. That's less than 4. It's this way. Okay, these are overlapping. I got the red and the black. They are overlapping on this tail end, okay? So if I want to write this in terms of interval notation, it's negative infinity. I'm just writing the part where they overlap to -1. Okay, let's take a look at 4. If you don't understand something, pause the video, okay? Just raise your hand and ask me. All right, subtract 10 from both sides. Excuse me, not both. The middle, the left, and the right and the left. That's 90. Let me do this in black. Less than 10n, less than or equal to -80. Then you're going to divide the middle by 10, the right by 10, and the left by 10. So we get 9 less than n less than or equal to -8, guys. All right, so this one I'm going to be careful. I'm going to split this because this is my larger number. This is my smaller number. But yet I'm using less than symbols when the larger number is first. Keep in mind I said normally what you'll see if the less than symbol is or less than symbols are used, you'll see the smaller number first. But I'm using less than symbols, but I see the larger number first, which is going to tell me that I have one of these special ones, okay? All right, so I'm going to break this up into n Let me use a different color. N less than 9, which I'm going to switch and make N greater than 9. You can switch sides. And then if I just look at this part, that's N less than or equal to -8. So I'm looking for all the numbers, and then again, -8's not on here. Okay. Looking for all the numbers less than or equal to -8. So that would be those. And all the numbers greater than 9. My goodness. Draw it out, guys. 6, 7, 8, 9, 10. Draw it out like that, okay? It's greater than, so it's going to be an open circle. And it's going to shade to the right. These are joined by and. You can tell that because of the way it's written. So this will be no solution. Trying to see if I can get to all real numbers. And I don't think I have any on those. Let's get to some ors. Let's not skip 5 and 6. Let's get to some ors, okay? Okay, let's look at 7. N plus 2. I think the all real numbers is going to be on, ors. In order for it to be all real numbers on the and, they will have to like overlap at every single place, which means your inequalities will have to be the same. So you wouldn't ever have a all real numbers on the and, okay? You can have a no solution on the and because they don't have to intersect. Okay, subtract 2 from both sides. Here I'm going to divide by -4, but you're dividing by negative. So let's switch greater than to less than, guys, when we do this, okay? So then we'll go back and we're looking at n less than 5. And keep in mind this is joined by or, okay? So I just need either or. Either one of those solutions. So I'm looking for everything greater than -9 and everything less than 5. Yeah, we're going to have to draw this out again. Five's on there, okay? So look for everything greater than -9. So move. These are ors now. You keep going. Okay, so just keep going, and we're not looking for an overlap. Just keep that in mind. That's on ands. So I'm looking for everything greater than -9. That's that. And then for everything less than 5, I need the pen, please. So I can get rid of the red. Okay. Everything less than 5. Well, all of this is less than 5. Okay, if I keep going, I'm going to shade it. I shade it in green. All this is less than 5. Okay, but keep in mind, you're not looking for that where they overlap, because this is joined by or, okay? So what you're doing is just trying to see what's shaded. You're putting down every part on the number line that's shaded. So for or, you look for all shaded regions, because that becomes your answer. Okay, but everything's shaded. So this one is all real numbers. Let me separate so the number symbols don't look like an L. Okay, all real numbers. Okay, but keep in mind, or you're just looking for all shaded regions. For and, you're looking for the overlapped regions or region. Okay, let's take a look at 8. All right, this one I'm going to multiply both sides by 5. So I'm looking for any answer that's less than -5. This one I'm looking for any answer less than or equal to 7. Okay. I don't understand why. Okay. This has -5. You only have -5 on the number line. Okay, I'm gonna do one thing, guys. I am going to get rid of this negative, okay? Take that negative off. I don't feel like dealing with that and drawing all the way to -5. That's crazy. Okay, take that off. Take that off. We'll do that. Okay? We'll do it that way. So I'm looking for everything less than 5. Okay. That's everything less than 5. And then I'm looking for everything less than or equal to 7. So here's 7. Do it in black. But I need everything less than that. Okay. All these are less than, I'm trying to go with the highlighter. All that's less than 7. Okay. So again, for OR, you're not looking for the overlap. I know it overlaps on this tail end back here, but that's not what you're looking for OR. For OR, you're looking for anything that's shaded. And so if I just say n less than or equal to 7, that will take care of everything that's shaded because all this is shaded, okay? So you're just looking for all shaded regions on OR. So that would be negative. Let me do this in black. Negative infinity. Negative infinity up to 7 with a bracket, okay? So that's the entire shaded region from 7 down to negative infinity, guys. So instead of splitting, they both go in one direction, but you still list the whole shaded portion. You write down something in interval notation that will take care of like the entire shaded portion on your number line. So important to graph these if you got special cases in them. Remember, OR is normally split, and you could tell this one wasn't going to split because that's less than. The smaller number is less than, but the larger number is also less than. It's another special case. All right. 9x minus 9 less than -99, or 2x plus 6 less than 18. Just going to add 9 to both sides. So you're looking at 9x less than -11. Why is the 11 coming? Because I'm thinking about 99 divided by 11. By 9. I'm sorry, guys. It's 5:30 in the morning. All right, -90. Divide both sides by 9. Here, subtract 6 from both sides. So we end up with 2x less than 12. Divide both sides by 2. And x is less than 6. Both of these are going in the same direction. They're not going to split, but it's going to be, you got to give me a one-directional answer because it's OR, okay? Because they're going in one direction. So instead of a two-directional answer where they split, it's just a one-directional answer. It's okay. When I say one-directional, like this one, it's just going, all that's going to the left. Okay. All right, let's take a look. Everything less than -10. My goodness. Okay. This is what I'm going to do. I'm going to say -10 is over here somewhere. And it is. Okay. All right, so I'm going to pretend like -10 is right there without ordering the whole number line. Because I don't have that kind of room. And then everything less than 6, you're not looking for where they overlap, guys. I know they overlap on that tail end, but I don't have an and statement. I have an or statement. So I'm looking for anything that's shaded. So anything that's shaded will be from 6, not including 6, and to the left. That's going to be negative infinity up to 6. Okay? Okay, we'll do 10. I think I'm going to call it quits. All right, let's do 10. If you have questions, ask me. Just stop the video and ask me. So I have 3x greater than or equal to 27. Divide both sides by 3. So you have x greater than or equal to 9. Here it's negative 4 on both sides. That's your zero pair there. You get negative 24 when you add those together. Divide both sides by 4. And x is greater than or equal to negative 6. It's one directional again. They're both going to the right. Okay, 9 and negative 6. Well, here's negative. Let's get 9 out of the way. 9 somewhere over here, guys. Negative 1. That's these people. All right, 1. I'm going to try to make it fit. Okay. All right, everything greater than or equal to 9 will be this section right here. And everything greater than or equal to negative 6 will be all of this. Now, let me do a different color. Different color. It'll be all of that, okay? So I know they overlap on the tip, but again, it's joined by or. I'm not looking for the overlap. I'm just looking for everything that's shaded, okay? So that would be from negative 6 to positive infinity. All right, I hope this makes sense. If it doesn't, let me know. At this point, guys, go do the math lib now. But please, 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 if they're ors and they don't have opposite directions, then it's one directional. You're going to end up with one of these special cases, okay? If it's an or and the whole number line is shaded, that's all real numbers. Make sure you are graphing these, please. If it's and they overlap on the tail end, make sure you write that correctly. You got to look at the graphs. Please look at the graphs. All right, guys. Go do your math lib.